Okay. All right, so we're talking about factoring special cases. This is section 8.7. So in your notes, put a title there, put a date. So today is April 9th, 2013. This is the last section in chapter 8. And it's just a section to show you that there's some special things that happen, and it may look weird and different, but it's really the same thing that we've been doing. Okay, so let's take a look at just a couple examples. If I showed you this, a plus b squared, what do you think about when you see that? What does that really mean? A plus b squared. Yep. All right, so you're thinking that it's a squared plus b squared, right? All right, not necessarily. Yes. All right, so that's correct. So it's not a squared plus b squared, okay, which is, very common to think of it this way. We would just say, oh, the squared drops down to each term, but not when there's a plus sign. Okay, when there's a plus sign in between there, a plus b squared is actually a plus b times a plus. Okay, so we've got this binomial a plus b multiplied by itself twice. So if you see a square like this outside of the parentheses, it means that everything inside is duplicated. All right, so if I was going to try to get rid of the parentheses, and using my little square technique that we learned before, I put a and b on each of the sides here. Okay, what polynomial does that get me? Remember how to do this one? We do a times a, which is a squared, a times b, which is ab, a times b again, and then b times b, which is b squared. All right, so when I unpack this and turn it back into it'll be a trinomial, I can combine these two together. Here I have one ab and then another one ab, so that makes a total of 2ab plus b squared. So, originally when we set up here at the top that it equals a squared plus b squared, we would have been missing this middle term, which is the 2ab term. All right, and the fact is that we have to go back and through and do this FOIL method or the square method in order to get that polynomial. All right. So what we call this right here, this is called a perfect square. Perfect square trinomial. Okay, and it's a perfect square because what we end up having is the same binomial multiplied by itself twice. All right? And this term and this term, the front and the back term, are perfect squares. Okay? And so, the fact that these are perfect squares makes the trinomial a perfect square trinomial. So that's just the first thing that I wanted you to recognize. And so what we're going to do is let's look at an example of this one. And really there's nothing different about this other than the fact that when we simplify this or when we factor, we can take it one step further. So let me give you this example. X squared minus 12x plus 36. All right. Use the same procedures that you've always used to factor this. All right, so our goal is to break this trinomial down into two binomials. All right, we want to split it down into two binomials. So it's the same rules, same procedures that we've always used, and we want two numbers that multiply to make 36, but two numbers that add to make negative 12. Can you think of two numbers that multiply to make 36 but add to make negative 12? Charles? Yeah, negative 6 times negative 6. When we multiply negative 6 times negative 6, we get positive 36. But when we add them together, we get negative 12. So that's our combination. Now, why is it a perfect square? Well, because it's the same number multiplied by itself. Negative 6 times negative 6 makes it a perfect square. So the fact that we're dealing with a 36 there, and we know that one number multiplied by itself will equal 36, that leads us into the fact that this might be a perfect square trinomial, and it's a special case. So it's done the same way, and I'm going to write my x's up front like I normally do. And since I know that negative 6 times negative 6 equals positive 36, I'm just going to write in my negative 6's like this. Okay? So x minus 6 times x minus 6 is our factored answer. But can't we simplify this one last time? We have the same thing multiplied by itself. So it's just x minus 6 squared. That's it. All right, so for the first part today, it's just a matter of recognizing that perfect square trinomials have, one binomial multiplied by itself 2 times. And so we can just simplify that last step and make it a square. All right, questions on that? Okay, now you guys try one. I'll give you an example here. How about v squared minus 10v plus 25. Okay, I'll call this example 2. V squared minus 10v plus 25. So go ahead and figure out what the factors would be using the same procedure. Okay, so we're making our chart again, and we realize that we need to multiply two numbers to make 25, but add the two numbers to make negative 10. And so the two numbers that multiply to make positive 25 are negative 5 times negative 5. We add those to make negative 10. So that's our combination. Okay, so v times v will make v squared. That's why we put the v's up front. And minus 5 and minus 5. Okay, are we done? Pretty close. We can just now, since both of these are the same, we just say it's v minus 5 squared. So really the only difference today is just recognizing that when the two binomials are the same, we can just combine them one last time and say that that's a squared binomial. Okay, we call these perfect squared trinomials, actually. All right, the second part of today is factoring the difference between two squares. Factoring the difference between two squares. Okay, the difference between two squares means two squares subtracted. So difference means subtraction. All right, so I've got, first I want to show you, if I had a plus b times a minus b, a plus b times a minus b. Factor this out using our little square chart method and tell me what the trinomial looks like. Go ahead and do that really quickly. Okay, so a times a is a squared. A times negative b is negative ab. A times b is positive ab. And then b times negative b is negative b squared. All right? So Now that we've gotten that square done, we can unpack these and put it into a trinomial. So a squared. Here we have 1ab, and this is negative 1ab. Positive 1ab plus negative 1ab equals 0ab, which disappears. It's gone. All right, so I'm going to write it out just for right now, but this is 1ab minus 1ab minus b squared. Okay, so I want you to recognize, and why this is a special case is because these two middle terms right here, they equal 0. So they kind of, cancel each other, make 0. They disappear. They're gone. So now my answer is a squared minus b squared. Okay, so I actually end up with this binomial that, because the middle terms canceled or equaled 0. So this is an important relationship to understand, because if I start you with this, if I start you with a squared minus b squared, can you go backwards to this? Well, you realize that if I have a squared minus b squared, if there's a subtraction sign in here like this, then something must have canceled. If you don't see a middle term, an AB middle term, then something must have canceled. And what you probably recognize is that, A and B are the same, except one is plus and one is minus. All right? So when we go backwards, we could recognize that, it's just another special case. So let's try an example on this one. If I gave you this, z squared minus 9, okay, and I said factor that out into two binomials. Z minus 9 can be factored into two binomials. We know that the middle terms are canceling, okay, and so here's the trick on this one. I think this is example 3. So I have z squared minus
Teachers, please excuse this announcement, but at this time, can you please dismiss any freshmen with the last names E through J to the small gym at this time? Once again, that was freshmen only to the small gym, letters E through J. Thank you.
Okay, so you've got to go to the small gym. They're doing vision testing. So if you're E through J, who's E through J? Nobody? All right, awesome. All right, so z squared minus, now instead of 9, I'm going to write 3 squared. I realize that 9 is actually 3 times 3. Since we're talking about perfect squares today in special cases, what'll happen here is that this number will always be a perfect square. And so basically, I'm just trying to figure out what two numbers make that number. If I multiply 3 times 3, that makes 9. All right? And so now that I've got z squared minus 3 squared, I can create my binomials from this. So how is this similar to this? Well, down here I said that a squared minus b squared was the answer to that setup, this binomial. And so, a's would go in their spot, and the b's would go in their spot, and one would be positive and one would be negative, or, one's plus and one's minus. So I'm going to put the z's in their spot, and I'm going to put the 3's in their spot. But this is the only little piece here that you have to remember, is that when we're talking about these factoring differences of two squares, when the middle terms cancel, I've got to have one as a positive 3 and one as a minus 3. Okay, one has to be plus 3, one has to be minus 3, because now I'll get the canceling happening inside. All right, so that's the answer right there. Just to show you, if I continued just to check myself on this, and I put z in 3 here, and then z in negative 3, get z squared, get my negative 9 back. Z in 3 is 3z, and then z in negative 3 is negative 3z. Okay, so you can check to see, do these two cancel? Do they make 0? Yeah, 3z plus negative 3z equals 0z. And so I end up with z squared minus 9, which is what I had in the beginning. All right, so what's my procedure here? Step 1 was to basically find a number when multiplied by itself equals that number. Okay? So what number, when multiplied by itself, equals 9? Well, it's 3. Okay? If that was a 25 there, what number, when multiplied by itself, equals 25? 5. Okay? If this was a 64, what number, when multiplied by itself, equals 64? 8. All right, so basically what you're doing is you're breaking this term, or this coefficient, down into a squared value. All right, so then step 2 in our procedure is we're going to drop in our values. So you're going to drop in the z's, and you're going to drop in the 3's. Okay, so those get dropped in accordingly. And then 1 becomes positive and 1 becomes negative. And that's basically it. So you're piecing this together based on what we saw that happened with our A's and B's example. We're just seeing the relationships here between z, the z squared minus 9, and we're able to create our binomials from that. All right, so step 2 is to drop our coefficients into their places in the two binomials. Okay, this last step here is just to check our work. All right, any questions on that type of problem? There's only 2 different types of problems today. Should we do one more? Try one more. How about y squared minus 121? What 2 binomials would make y squared minus 121? Obviously, the middle terms cancel. So what's the first step? What do I do with this term right here? What 2 numbers make 121? What is it? 11. 11 times 11. So really, this is y squared minus 11 times 11, or 11 squared. Yeah, go ahead. So I'm going to drop my y's in, drop the 11's in, and so I end up with y minus 11 and y plus 11. So really, there's not as many steps here. If you could just recognize the form that you're looking at, whenever the middle terms are not there, whenever the middle terms are missing, you're probably dealing with a difference of 2 squares trinomial. Okay? I'm going to stop us right here.